Every day, a modern government faces an overwhelming, chaotic barrage of societal demands. Rising unemployment, shifting demographics, sudden infrastructure failures. Thousands of uncoordinated problems flooding into a central hub, demanding immediate intervention. The sheer volume of these inputs creates a serious engineering problem. With limited resources, governments must determine how to isolate the correct intervention without relying on political intuition or guesswork. To solve this, states employ a multidisciplinary engine known as policy analysis. It is a rigorous process that combines political science, economics, law, and statistics to systematically examine public problems and evaluate competing alternatives. The primary objective of this system is to remove instinct from the equation. It shifts decision-making towards evidence-based optimization. To function properly, this system must generate three core outputs. That has to accurately isolate the exact problem, map out the possible solutions, and project which of those solutions will produce the most effective result. Effective governance requires translating chaotic social variables into structured, measurable data. This is achieved through a continuous, rigorously tested policy lifecycle. Every state intervention begins with the first phase of this macro lifecycle, precise problem identification. Unless a societal flaw is accurately diagnosed, no meaningful blueprint can be drawn. However, recognizing a problem does not guarantee action. The issue must survive agenda setting. This is the political filtering mechanism that determines which issues receive immediate government priority and which are delayed. External shocks often force rapid agenda setting. When severe floodwaters devastate a region and citizens are left carrying debris across ruined infrastructure, disaster recovery bypasses the usual political filters and demands immediate, mandatory state intervention. Once an issue secures a place on the agenda, it enters the most rigorous phase of the life cycle, policy formulation. Formulation acts as a nested internal system of 11 sequential steps. It begins by establishing precise, measurable objectives. Analysts avoid designing a single linear solution. Instead, they generate multiple distinct alternative paths. Relying on one option introduces risk. Practicality requires comparing different operational designs. Formulation acts as the critical analytical bridge. It takes raw political intent and transforms it into a structured, executable blueprint for action. This matrix shows how analysts grade those competing blueprints. To find the optimal path, they must subject each alternative to strict evaluation criteria. The blank columns populate with 4 specific metrics: effectiveness at solving the problem, economic efficiency, social equity, and political feasibility. The primary mathematical tool used to fill this matrix is cost-benefit analysis. It forces the state to weigh the expected upside of a policy against the sheer gravity of its costs. Those costs are strictly quantified into 3 categories: the direct financial burden of the program, the administrative overhead required to run it, and the social costs absorbed by the public. Analysts pair this calculus with a thorough risk assessment, stress testing models to expose potential failures. To finalize these calculations, experts gather hard evidence from census records and surveys, resolving the empty matrix cells with concrete quantitative values. The final output of the formulation phase is an evidence-based recommendation. By comparing the criteria across the board, analysts select the alternative that achieves the highest aggregate score in the matrix. This mathematical calculus allows the government to efficiently deploy its limited resources toward the most optimized, practical solution available. At this point, the theoretical modeling ends. The recommended blueprint advances to policy adoption, where it transitions from a proposal into an official mandate. Adoption occurs through formal state mechanisms. This requires passing legislation through governing bodies, like the Parliament House of India, or through direct executive orders and binding government regulations. An adopted law is only a piece of paper until it reaches policy implementation. This is the crucial, high-stakes phase where legal text is translated into physical, ground-level action. Consider a rural employment guarantee scheme. Implementation is the physical deployment of that policy, organizing thousands of workers digging and carrying earth, delivering promised wages, and constructing localized infrastructure. Executing this requires massive state mobilization. Governments must secure and allocate continuous funding. establish bureaucratic institutions to oversee the work, and deploy specialized training for officials on the ground. This introduces the concept of implementation feasibility. A mathematically perfect policy will collapse immediately if the state lacks the logistical capacity, trained personnel, or political support to actually run it. The ultimate success of policy analysis is inherently bound to the state's physical ability to execute its own designs. Up to this point, the cycle appears mathematically clean, but real-world governance operates in a high-friction, deeply chaotic environment. Once a policy goes live, red, distorted static invades the system. This node network illustrates the first source of friction: interconnected complexity. A core issue like poverty is inextricably linked to education, healthcare, and employment. Because the variables are tied together, adjusting one node inherently destabilizes the others. Isolated solutions are impossible in a deeply connected society. Next is the friction of data limitations. Analysts rarely have a perfect view of the board. Entire sections of a population's data may gray out or remain completely undocumented, forcing governments to execute massive operations with incomplete information. Then there is pure uncertainty. Unpredictable future variables like sudden economic crashes, global supply chain failures, or pandemics can instantly derail the expected outcomes of a perfectly formulated policy. Furthermore, state action is constantly pressured by political influence and conflicting stakeholder interests. Different demographic and corporate groups frequently demand mutually exclusive outcomes, forcing compromises that dilute the original blueprint. This leads to deep ethical challenges. Designing a policy that mathematically maximizes efficiency for the majority often means actively disadvantaging a vulnerable minority. Balancing that fairness is an ongoing struggle. Modern policy analysts do not operate in a sterile vacuum. They spend their careers navigating the intense friction between objective mathematics and the chaotic reality of human politics. Because of this constant friction, the process does not end when a program goes live. Implementation is just a midpoint. The state must conduct mandatory policy evaluation. Evaluation audits the active program against its original, measurable objectives. It asks the hard questions. Did unemployment actually decline? Were the funds properly utilized? Where are the systemic shortcomings? The answers to those questions drive policy modification. As a policy affects a population, citizens' lived experiences generate new demands and feedback, forcing the state to adapt its approach. This feedback seamlessly closes the loop. The new demands generated by an old policy become the new problem identification, restarting the entire life cycle from the very beginning. Policy analysis is the indispensable engine of modern governance. It is the only reliable method for bridging the vast gap between strictly limited state resources and maximum public welfare. By mastering this cyclical architecture, a state can elevate itself above purely reactive politics, achieving informed, accountable, and systemic democratic governance.